Welcome everyone. Guys, can you see me and hear me? Just let me know, everyone. So how is everyone? First of all, everyone tell me how are you guys? Then we'll start with the session, right? So today is the first session of, you can say, Wave Optics. So Yash is there, Divya is there, Beena is there. Beena, hi. Okay, Big Boss News. Nice name. Good. I'm just adjusting the screen. Just give me a few moments. Yeah. So Farid is there. You are well, Big Boss? Big Boss should be well. Anand Lok. Okay, Anand Lok, first view. Good. Congratulations. Anuradha Sharma, hello. So how's everyone? Let me know. And today we are going to start with, you can say, wave optics first session. Okay, so first session of wave optics, and we'll be discussing like two or three most important formulas in this chapter, which is like which comes every year in every exam. Okay, Sahaj. Acha, Sahaj, you're also there. Good. Hi. Hi, Sachin, Divya Jyoti. Okay, so let's start with the session, right? Let's start with the session without any further delay and without any talking. Okay, Apurv, obviously I remember you, right? I'm your teacher, right? So how can I forget you? So we are going to discuss few questions which will be based on Shruti Sharma. Okay, Shruti, by the name Anirudh, right? So everyone, just let's get started, right? So few important formulas on which you can see we'll be solving questions. So let me know if you guys remember these formulas. So intensity at any phase difference phi is equal to I max cos square phi by 2. Yes, I remember Sahaj. Okay, now just listen to what I am trying to teach. Okay, Alok Kumar Sharma. So how many of you remember this one? I is equals to I max cos square phi. So this formula relates intensity with phase difference, or you can say if there are two waves which are like interfering with each other, if the phase difference between them is phi, so what will be the intensity? Yeah, Apur, I got your point. Okay, so I is equals to I max cos square phi by 2. This is the first formula. Second is the relationship between path difference and phase difference. So as it is written over there, you guys can see it very clearly. This is a chapter. Divya is asking me which chapter. Divya, this is wave optics, and you should be knowing it, but that is fine. Okay, so path difference is equals to lambda by 2 pi into phase difference. The third one, polarizer. How many of you know about polarizers? You must be knowing it, right? So what happens when you can say two polarizers are inclined at an angle of theta, let's say. So the resultant intensity is I cos square phi. So we are going to do questions based on these three formulas. So if you guys are clear with these formulas, let me know. Go ahead and let me know, guys. I'm you can say seeing your chats. Okay, so you can respond. I'll be responding as well. Okay, so I is equals to I max cos square phi by 2. This is the intensity, you can say, at any phase difference phi, and path difference is equals to lambda by 2 pi into phase difference. And polarizer, what is the intensity of, you can say, what is the intensity of the emergent wave if the two polarizers are making an angle of theta. ठीक है, good. Good. So it is I cos square theta. If you guys are so clear, okay, if you guys are so clear, tell me the answer to this one. Let's see how many of you can do it, because you guys said you guys are clear, right? Okay, so just let me know. Ambika, you will get it. Okay, so just write these three formulas, Ambika, and based on those three formulas, let's see if you guys can solve this question. So I'm reading it for you, and try your best. But then after some time, I'll just tell you the solution of this one, right? So in the Young's double slit experiment, using a monochromatic light of wavelength lambda, the path difference in terms of an integer n corresponding to any point having half the peak intensity is. So just a simple formula based question that too came in 2013 JEE Advanced. So let's see how many of you can solve this question. Go ahead. So the first formula you have to apply over here. Let's see if you guys can get it. So let me know if you guys are able to relate to this one. Okay. So I is equals to I max cos square phi by 2. So from there you can see I'm solving it. You guys keep watching. Okay. So what is the formula which relates maximum intensity with the intensity at any phase difference phi? So this is the formula. That is the first formula I told you right before. So in this question, the you can say it is given. The intensity is given and it is half the peak intensity. So I is given as I max by 2. So all you need to do is just put that value in the formula. So just putting it back over there, so it becomes I by 2 is equals to I max cos square phi by 2. Very good. Now these two cancels because you can say they are equal, I max only, right? So we'll be getting half here and cos square phi by 2. Now, how many of you can tell me the general solution for this one? You guys are mathematics students, so you should be knowing this one. So general solution of this equation, go ahead. It's a kind of a mathematical question. So it will be pi by 2, comma, 3 pi by 2, comma, 5 pi by 2, if you guys are fine with that. Okay, someone is answering, Divya is answering B, and I feel that she's correct. Okay. So this is what I am getting. Okay, and now what is the path difference? What is the formula for path difference? Is equals to lambda by 2 pi into phase difference. Okay, so phase difference, I actually calculated phase difference over here, and I have to find path difference, right? So good. Now putting these values, we can see delta x is equals to lambda by 2 pi into phase difference. Now if you keep on putting these values like first here, second here, and then third here, then you will see lambda by 4, 3 lambda by 4, 5 lambda by 4. Okay, which in AP can be written as 2n plus 1, okay, lambda by 4. So guys, can you see the options? Okay, Anjali is coming up with the correct answer. Divya, Jyoti is also correct. You can say correct, and Divya is also. So two Divyas, right? Good. So the correct option is B. So how many of you got this one? Let me know. Then we'll move to the next one. Go ahead. You guys are fine with that? It was, you can say, a hybrid of two formulas. First formula right over here, and the second formula is very simple relationship between phase difference and path difference. Let's move to the next one. Let's see how many of you can solve this one. Divya, Anjali, or who? Okay, let's see. So this is based on polarizer. A beam of unpolarized light. I'm reading it for you. Let's see if you guys can get it. So a beam of unpolarized light of intensity I naught is passed through a Polaroid A. Okay, and then through another Polaroid B, which is oriented such that its principal plane makes an angle of 45 degrees relative to that of A. Okay, the intensity of the emergent ray, it should be easy. Let's see how many of you can do it. Angle is given, formula is right there. Apply it. Let's see. I feel that you guys will get a wrong answer, but still, just let me know what is your answer. Okay, go ahead. Gaurav says C. Okay, Gaurav, we'll see if it is C. Okay. What about others? Prince also says C. Good. What about others? I want everyone to answer this question. Okay. So there is a polarizer A whose principal axis I'm making. Next polarizer is also placed at some distance from this one, such that these two axes, or you can say principal planes, are making an angle of 45 degrees. Good. So if I see in terms of this one, okay, let me just complete the diagram. This diagram is not going correct. Good. Okay, so that axis is not linear, but it's still just adjust. Okay, so just let me know, this is A, this is B, and the angle between them is 45 degrees. So Gaurav says C. Prince also says C. So let me know what will be the answer. Other kids, okay, other than you can say Prince and Gaurav. So C. Sai also says C. So how many of you can tell me what will be the intensity over here? Means after passing through first polarizer, what will be the intensity of light after passing through the first polarizer? Let's see how many of you can answer that. Then we'll see if it is correct or not. Okay, so I'll just tell you, since the intensity of light which is entering polarizer A, correct, is I naught, so this will become I naught by 2. Half of it will be, you can say, blocked by the polarizer. Now here it is, you can say we are going to use the formula. You can say I cos square phi. So here it is I naught by 2 cos square 45 degrees. So how many of you can tell me what is cos 45? That is 1 by 2, right? So it will become I naught by 2 into 1 by root 2 whole square, because cos 45 is 1 by root 2. Good. Now just done it is, right? So I naught by 2 into 1 by 2. So I am seeing that everyone was correct. That is so cool, right? So the correct answer to this question is C. Okay. Which chapter? Beta, you should be knowing it, which chapter it is, but it is wave optics, beta. It is a topic from wave optics, so you should be knowing it. Next question, let's see how many of you can solve question number 3, which was asked in 2005, 2 marks in JEE Advanced. So Anjali says sine inverse 3, or you can say lambda by 3D. So let me just read the question for everyone. In Young's double slit experiment, intensity at a point is 1 by 4 of the maximum intensity. Angular position of this point will be. So this is again based on the formula I is equals to I max cos square phi by 2. If you guys are fine with that, let me know. So it is given 1 by 4. So I max by 4 it will become is equals to I max. Okay, prettiest. Okay, your name. It's me, the prettiest. Wow, awesome name you got, right? Good. YouTube gives you the liberty to name yourself, right? Good. So it becomes cos square phi by 2. Okay, so these two cancel. We are left with 1 by 2 and cos square phi by 2. So how many of you can tell me what is the value, or what will be the value of phi? Solve this simple mathematical equation and let me know. Go ahead. Go ahead. Just let me know if you guys can solve this one. So it will be 1 by root 2, and go ahead. Let me know. Okay. So you can very clearly see cos phi by 2 is going to be 1 by 2 under root. Okay. Under root. I'm taking under root. And Anjali, just hold on. Let me just solve it for everyone, right? You may be correct. You may not be correct, but I feel you are correct, but still let everyone understand it, right? So 5 by 2 is going to be, so cos is half at pi by 3. So what is the value of phi I am getting? Let me just change the color of the stylus. So phi I am getting is 2 pi by 3. Correct. Now if you got phi, can you tell me what will be delta x? That is path difference. So you just need to use the same formula which I told you in the very beginning, right? So here delta x can be written as 2 pi by 3 into you can say lambda by 2 pi. Okay, so 2 pi cancels. So path difference comes out to be lambda by 3. This is the path difference between those two waves. Now, there is one formula for, you can say, relation of path difference with angular position, that is d sine theta. We are done with the question. Okay, so this is lambda by 3, it is d, it is sine theta, and they're asking you what is the value of theta. So it becomes lambda by 3d is equals to sine theta. Now you guys know theta will be sine inverse of that value. Okay, sine inverse lambda by 3D. So just let me know which option is corresponding to this one. Anjali, you were correct. Good. So everyone, just let me know if you guys all three questions. Okay, go ahead, keep responding and let me know. Okay, so the answer to this question is C, that is sine inverse lambda by 3D. So a quick revision, it will be like I discussed in this session three very important formulas. I is equals to I max cos square phi by 2. That is the, you can say, resultant intensity when the phase difference is phi. Next thing we covered in this session is path differences lambda by 2 pi into phase difference and polarizer. We discussed another important thing that is a favorite to, you can say, examiners. So what is the intensity of emerging light once it passes through a, you can say, polarizer? So guys, this is enough for today. Okay, subscribe to the channel, and you can say, to know how Meritnation can boost your preparation for JEE with power packed premium courses, go to this link. Okay, and send us your details. Okay, so I think this is enough for today, guys. We'll be meeting in the next session, which will be the same session, or you can say session with the same chapter. Okay, so this is enough from my side. Guys, take care and keep studying.